welcome to lecture number 46, design patterns. So, what are design patterns? So, we talked about the template, right, generics, the reusable. So, similarly, when I talk about design patterns, they are also reusable solutions to common problems in software design, right. So, in fact, this is providing a blueprint for solving issues related to object creation. So, when you are creating or instantiating an object, right, and then the communication, and then for behavior. So, we categorize this based on the purpose and usages. So, here we have design patterns like a singleton, factory, observers. So, they are not specific implementation, but these are all helpful or serve as a guide for structuring our code very efficiently, right, and effectively as well. So, what are all the advantages of using design patterns? So, we can use this for code reusability and easy for the maintenance, and we can have the improved communication. That means the patterns provide a common vocabulary for developers, flexibility. So, we have, right, these patterns are useful for extensible and scalable software architecture and reduce development time, right. So, patterns help solve recurring design problems very efficiently. So, what are all the types of design patterns? So, we have creational patterns, structural patterns and behavioral patterns. So, under creational patterns we are going to see what do you mean by singleton, what do you mean by factory, alright. So, what do you mean by builder. So, these deal with object creation mechanisms, and similarly when I am talking about adapter, decorator and composite, so these focus on class and object composition, alright. So, this is under structural patterns, and when I am talking about behavioral patterns, we are going to have observer, strategy and command. So, these patterns handle object interactions and communication. So, why are design patterns important in software design, right? So, mainly we have consistency, efficiency, scalability, robustness and problem solving framework. So, the meaning of consistency, so it promotes standardized solution across teams and projects. Efficiency, it reduces development time by providing proven solutions. Scalability, which is ensuring the software can handle growing requirements seamlessly. Robustness, improve code quality by addressing common design pitfalls, and the problem solving framework, so provide templates to tackle complex design challenges. So, if you have any, right, a very hardcore problem or very hard problems, so in that case these are all providing templates to tackle the complex design challenges. So, now how to implement design patterns in object oriented programming. Abstraction, leverage abstraction. So, we talked about abstraction, right. So, these design patterns use abstract classes or interfaces to define generic behavior. Then we have encapsulation, polymorphism, alright. So, these are all the cases we can implement design patterns in OOP, and delegation, right. So, this assign responsibilities to specialized classes or objects. So, examples in OOP, right. So, we are going to see a singleton, factory and observer, as I already said. So, singleton, which is enforcing a single instance of a class, right. So, we are going to talk about the single instance of a class. Factory, so this is helpful to create objects without specifying their extra class, right. And then observer, so observer notify multiple objects of changes in another object, right. So, this is what we are going to see in the design pattern: singleton, factory and observer. So, now I will start with a singleton pattern. So, what do you mean by singleton pattern? So, singleton pattern ensures that a class has only one instance globally, right. So, it will have a single instance, that is why its name as a singleton. I mean, in mathematics you have a singleton set. So, it is a single instance, right. So, the class which is having only one instance. So, this instance is accessible through a global point of access, right. So, commonly used in scenarios where the shared resources, configurations or logging are needed, right. So, we are going to talk about the shared resources, configurations and logging, right. So, what are all the main features? So, we, as I already said, it is having single global instance, alright. So, controlled instantiation, right. So, when you are creating an object, you have the control instantiation, and the singleton pattern which simplifies access to shared resources, right. So, I will give this with an example, the singleton pattern with the analogy of the coffee machine, right. So, in an office or any working place, you can find the coffee machine, right. So, what is the purpose of coffee machine? It saves resources and ensures consistency, right. So, the main idea is, right. So, instead of having multiple coffee machines, all right. So, the singleton, this is acting as a single shared coffee machine. So, one coffee machine you can find, and then this is providing the functionality for everyone. In fact, it is providing the same functionality to everyone. Suppose in the department, right, I want to have a coffee machine, I will buy one coffee machine, right. So, this coffee machine will provide the functionality to everybody. So, in a similar way, so in a class we will have only one instance, right. So, like the coffee machine in the office, only one coffee machine, so which is serving the purpose for everybody. So, what are all the use cases for singleton pattern? So, we have global resource management, that means this singleton pattern is managing, right, shared resources like a configuration file or database connection, logging, centralized logging service which is ensuring consistent logging across the application, caching, right. So, a single cache instance which is avoiding the redundancy in frequently accessed data. The next one is the device drivers, all right. So, this is controlling access to hardware like printers or network adapters, right. So, we already saw this example, the coffee machine. So, assume that, imagine you are having multiple coffee machines, assume that in a department I am having 4 or 5 coffee machines. So, one is a waste of money, right, and the person has to do lot of work. So, before putting all the ingredients, right. So, if it is only one, I mean, I no need to waste money, and only one time I can put the ingredient in the morning. So, my work is also very less, right. So, when I have a multiple coffee machines, this leads to the waste and the inconsistency, right. So, that is why the single coffee machine, now we call it as a singleton, that is managing resources very efficiently. So, now we will talk about the implementation of singleton pattern in C++. So, this is very important. So, whatever we had seen the theory so far, and then you know what is the meaning of singleton, and you can have the analogy of coffee machine. That means a class will have one instance, one global instance, all right. So, let us consider the class singleton. In line number 3, we have class singleton, right. So, you have one private instance under singleton, right. It is a pointer variable instance, all right. It is a pointer object, correct. So, under singleton, which is static, and then we have one private constructor, right. So, here you have the private constructor, right, both are private, right. Singletons, the instance, right, the object, in fact, it is a pointer object whose class is singleton, and then you are having the constructor which is a private constructor, right. So, here you have a public, you have a function get instance, the pointer function, right, under singleton. So, now this is checking if instance is equal to null pointer, right. So, if the instance is pointing to the null pointer, that means there is no instance. If there is no instance, you create the instance, that is the meaning. Line number 13, you are creating an instance, new singleton, right, this is a constructor, and then if it is not required, already instance is there, you are returning instance, right, already instance is there, you are returning the instance. So, now you have one more member function, display message. So, this display message is displaying singleton instance, right, and then your class is over here, correct, and line number 23, you have singleton, all right. So, you have a singleton, in fact, the instance, star instance, we are initializing the static member, all right. So, we are initializing the static member, so which is null pointer, which is pointing to null pointer. So, this is a pointer, the instance is the pointer variable, right, pointer object under singleton pointing to null pointer, that means we are initializing the static member. So, now go to the main program, it is a global in fact, right. So, before main you are finding it is a global in fact, and in the int main. So, here we have singleton, let us call the function get instance, right. the pointer function get instance. So, get instance will call this, right. So, here you have the singleton object, right, singleton object. So, when I am creating this pointer object, right. So, the get instance function will be called, right. So, the get instance function will be called, that is equal to get in the right hand side you have singleton get instance, right. So, when this function is being called, if there are no instance, the instance will be created from line number 12 and 13. Otherwise, if the instance occur, so we know the singleton instance, only one instance will be there, the global instance will be there. So, that will be returned, right. So, return instance. So, whatever be the case, if there is no instance, instance will be created in line number 13. If there already instance occur, that will be returned in line number 15, right. So, then line number 27, the singleton small s, right. So, that is invoking display message. So, the display message you have singleton instance, right, that is a cout statement. So, this cout statement will be executed, right. So, when I run the code, we will get the output singleton instance, right. So, the main idea here is the class which has a singleton instance, right, one instance, one global instance in fact, right. So, like exactly office as one coffee machine. So, if the instance does not exist, we are creating, otherwise whatever the instance is being created, so that will be returned, right. And then when I am displaying this message, because the instance either created or already exists, all right. So, in that case, the when singleton in line number 27 invoking display message arrow display, because singleton is a pointer object, all right. So, the get instance, that is returning instance. So, the instance will be here, right. So, the right hand side it will be return instance. So, singleton is a pointer, right, pointer object. So, whatever you have written, so that will be pointing to singleton small s, and singleton when it is invoking display message, so singleton instance will be printed, right. So, this is what exactly happening, and this is an example for implementation of singleton pattern in C++, right. So, here we had seen the private constructor, line number 7 and 8, in fact, line number 8 you have private constructor. So, this private constructor ensures the class cannot be instantiated directly. So, that is what the private constructor is ensuring. And then you have static instance, correct. So, here you have the static instance, right. So, static singleton star instance. So, this is a static instance. So, the static instance, this is a pointer which is holding the single instance of the class, one coffee machine, right, in the office. So, in a class you are having the single instance. So, that is why you have static instance, and then you have a member function called get instance, all right. So, the get instance, here you go. So, that is what I said, if there is no instance it will create the instance, if it is already there, right. So, definitely line number 12 and 13 will not be executed, and if the instance is already existing, so that will be returned in line number 15, all right. So, creates the instance, if it does not exist, returns the existing instance otherwise, okay. So, this singleton implementation simplifies resources management by ensuring a single shared instance. Exactly, you have to think about the single coffee machine in the office. So, this class has a single shared instance. So, now in this program, so what we do, the implementation of singleton pattern in Java we will see. The last program we had seen in terms of C++, right. The similar or almost same program, right. Of course, the syntax will be different. So, we will see in the case of Java, all right. So, let us have public class singleton, all right. So, here you have a private instance under singleton, right. So, I am not worrying about star or address here. So, singleton instance. So, here I have a private constructor, correct. So, the private constructor, and here you go the public static, all right, the public static. So, under singleton class you have a member function get instance. If instance is equal to null, all right. So, you are creating a instance. So, instance is equal to new of singleton, which is a constructor, in fact, the private constructor. If the instance already exists, you are returning the instance, correct. Exactly same, whatever we have seen in C++, and here you have the singleton instance in Java, right. If it does not exist, we are creating the instance in line number 9 and 10. Otherwise, if it is already existing, you are returning it in line number 12. So, the next one is public void display message. So, the display message, it is printing singleton instance. So, now if you go to the main program, I have an object singleton, right, under the class singleton, correct. So, the singleton, the class, right. So, which is invoking get instance, right. So, slightly modified version we had seen in C++, right. So, here this is invoking, right. I hope there the object is invoking, right. So, otherwise it is equivalent, right. The singleton class in the left hand side, dot operator, and here you have get instance, right. So, when it is calling get instance, if the instance is not there, instance will be created and then it will be returned. Otherwise, if the instance already exists, it is like if you do not have a coffee machine, you are buying a coffee machine. Suppose I have a coffee machine in the office, I no need to buy, right. So, if the instance in the class does not exist, you are creating the instance in line number 9 and 10. Otherwise, it will return the instance in line number 12. Okay. And the line number 21, the singleton, the small s, the object which is invoking display message. So, when it is invoking display message, the singleton instance will be displayed. So, when I run the code, I will get the output, the singleton instance. Okay. So, this is the case of Java. I hope it is clear for everyone. So, here similar. So, I had the private constructor in the case of Java. So, this prevents direct instantiation of the class. Right. So, I cannot directly instantiate an object, right. So, that is why line number 5 you have the private constructor exactly same what we had seen in the case of C++, and here you have a static instance, right. So, that variable holds a single object, and get instance which is creating and returning the instance if it does not exist. Otherwise, it is providing the existing instance we had seen, all right. So, it is very easy to implement, and also it is ensuring consistent resource management. So, now we will see, in fact we had seen, right, there are certain applications, the logger system using singleton pattern, all right. So, let us have the class logger, and here you have a private, right, the object pointer object instance under logger. So, we have included IOStream and string, right, and then you are having the private constructor exactly like what we have seen in the case of singleton, right, almost similar. So, now if instance is equal to null pointer, right. So, here you have the get instance member function under, right. So, this is a pointer function under logger, pointer function under logger. If instance is equal to null pointer, if it is not pointing to anything, or in the case of Java just now we had seen instance is equal to null, right. So, in that case you are creating the instance, all right, where a logger is the constructor. If the instance already exists, right, it will return, right. If it does not exist, we are creating exactly like what we have done in the case of a singleton class, all right. So, here we are creating an instance if it does not exist. So, that is happening in line number 11 and 12. If it is already existing, you are returning instance, right. So, line number 17 you have one member function called log message, all right. So, under log message you have a message, all right, the reference message under string, right, string address message cout. So, log will be printed and whatever message you are going to pass, so that will be printing. So, now I have, right, so before main the global one. So, I have instance, it is a logger instance pointer variable, okay. So, now I am creating over here inside the main, I have logger, right, small l, right, creating a pointer object, all right, under logger. So, in the right hand side get instance, right, this function, this member function is being called, all right. So, when it is calling get instance, so if the instance does not exist, we are creating the instance. If it is already existing, we are returning it, all right. So, otherwise the return whatever be the case, if the new instance right occurring, new instance is, right, you are creating it will be returned in line number 13, right, line number 14, and if it is already existing, it will return instance. So, instance will be returned, right, and then logger is invoking the right log message function, right. You are passing singleton logger initiated, right, singleton logger initiated. Yes, it is being initiated here, all right, because it is returning. So, now this will call log message, all right. So, log will be displayed, log colon will be displayed, and the message, what is the message you have passed? Singleton logger initialized, right, singleton logger initialized will be printed. And again line number 27, logger is invoking log message. So, logging an event will be printed, correct. So, that means log colon logging an event will be printed, right. So, this is what exactly happening. So, when I run the code, I will get the output like this. So, singleton logger initialized, and the next case logging an event, all right. So, this will be printed. So, this is all about the logger system. So, the logger system using singleton pattern. So, what it is saying, so it is ensuring, the logger system is ensuring a single instance for logging events throughout the application, right, only one instance, and we are using the global access, right. So, which is a get instance function, member function. So, this is providing a unified entry point, and any component in the system can use the logger instance to record messages. That means you have flexibility, and the main advantage is it is reducing the redundant logger instantiations, and also it is ensuring consistent behavior across the application. So, now let us have the configuration manager using singleton pattern. So, this program we will see using Java, right. So, this program we will see using Java. So, Java utility hash map, and if you look at the public class, which is configuration manager, all right. So, private static, you have a configuration manager under instance, all right. So, here you are having the class configuration manager, and you have an object instance, right, exactly like what we had seen, right, in the Java program for the singleton, right. And then you have the private class hash map, right. So, you are having data type string and string. So, configuration config, right, which is an object under hash map. So, instance is an object under configuration manager, and config is an object under hash map. So, now you have the private constructor configuration manager, right. So, here you have, so config, correct. So, it is already the hash map, right, which is equal to new hash map, right. So, here you have the constructor, right, for the class hash map. And here you see we have one get instance member function, right. So, get instance member function under configuration manager class, right, under configuration manager class. Again, if the instance does not exist, so we are creating an instance, right, otherwise return, right. So, even after creating, this will return instance, as we had seen in the previous cases, a logger and singleton. So, now if you look, so we have set config method, right. So, here you have key and two attributes, key and value, right, two parameters, key and value, whose return type is string, right. So, two argument function whose data type is string. So, now your config object is invoking put, right, put. So, you are passing key and value. So, key and value will be passed, right. So, inbuilt function like a puts and gets that we had studied in string, right. So, line number 21, you have get configuration method. Here you are passing, right, one argument key, right, one parameter key, and it is returning, here it is returning, right, the config will invoke get, right, and the key will be passed. So, now let us go to the main program. So, the main program, in fact, it is in the driver class is nothing but the configuration manager itself, right. So, driver class, we do not have any other class. So, it is under this driver class configuration manager. So, here in configuration manager, I am creating one object config manager, and in the right hand side, so this configuration manager which is invoking get instance, all right. So, get instance, when it is invoking, we know that if there is no instance, instance will be created, otherwise if the existing instance, line number 15 it will be returned. Even after creating also line number 15 will work, it will return the instance. So, now the config manager object, right. So, this object is invoking set config. So, set config you are passing app name and singleton app, right. So, that means key is app name and the singleton app is value, right. This the put function will do, and then you have one print statement system.out.println. So, this will be printed app name and config manager object. So, which is invoking get config, right. So, get config you have app name. So, that means your key is app name, key is what? App name. And what about value? Value is nothing but we already put. Can you tell me what is the value? Singleton app, right. So, this is your value, right. So, both will be printed. So, app name configuration manager, right. So, this will be printed like app name. In fact, this key will not be printed because config manager is invoking get config, right. So, get config you are having get of key, right. So, what is your key? Key is nothing but, right, singleton app, right. So, when I run the code I have to get the output like this, right, app name singleton app. This is what we are expecting and we get the output, right. So, this is how the configuration manager using single pattern in Java is working, right. So, the main idea is the configuration manager which is maintaining the applications wide settings in a single instance. Yeah, I am keep on talking about the single instance, and there are several features, the centralized storage for the configuration values, and similarly consistent access to settings throughout the application. So, the main usages are developers use setConfig function to define settings and use getConfig to retrieve values from anywhere in the application, all right. So, in the next class we will talk about the alternative singleton implementation in C++, right. So, in today's lecture, so we were talking about the single instance, all right, with the help of coffee machines, and then we had seen 3 different programs, all right, the mixture of Java and C++, all right. So, in the next class I will start with, right, the alternative singleton implementation in C++. Thank you.